Today, the study of optical device, that is compound microscope. In Hindi, संयुक्त सूक्ष्मदर्शी, यौगिक सूक्ष्मदर्शी. This is a device that we have to get function, structure and its magnification. So a compound microscope is an optical instrument as a device which magnifying the object in large visible scale. किसी भी छोटे से छोटे पदार्थ का विशालतम विजुअल स्ट्रक्चर की स्टडी के लिए हम लोग संयुक्त यौगिक सूक्ष्मदर्शी कंपाउंड माइक्रोस्कोप का इस्तेमाल करते हैं. इट इज एप्लीकेबल इन पैथोलॉजिकल लैब, scientific purpose and detecting smallest fine particles. It is also used in laboratory for practical purpose to detecting microbes as bacteria or virus, and also applicable in the examine of urine culture, stool testing, blood testing, coughing and their so on. As many of things, suppose some of the particles go inside our eye, go inside the throat by any means, and go inside our ear. We have to detect their position, their depth and their local appearance by this compound microscope. It is also applicable in testing of difficult language, that is historical language that we can't know about their meanings. It is helpful. The function of the compound microscope is to there have two convex lens. One is eyepiece and another is objective piece. Objective piece is smaller in focal length, where eyepiece is larger in focal length. Both the lenses, objective piece and eyepiece, are coaxial, situated on the same axis. The image of it we get under clear vision, so it is very magnified optical instrument, give a quality, give a visual scene of anything that is teeny, smallest and fine particles. A structure of the compound microscope, as you see on the board, two concave lens, EO, that is objective piece, and EE, that is eyepiece. Both are on the axis. They are adjusted on axial axis. An object PQ is placed in front of objective piece. One of the ray from the vertex incident on the eyepiece and converge to cut PA and fall on the eyepiece, that converge to the observer on eye. Again, the other ray that is incidented from the vertex of the object through the optical center of eyepiece and go forwarded to cut first refracted ray and fall on the eyepiece and go forwarded to the observer. The point where both the refracting ray cut together, that point is said to be vertex of the object, that is Q dash. Now, from the Q dash, we have draw a perpendicular P dash Q dash, which is the image of the object, that is the first image. And now the refracting ray that converge to the observer, that can proceed back, which meet together at a point just back to the P dash Q dash and meet at Q double dash. Now a perpendicular is drawn from the Q double dash to the principal axis P dash Q dash, which is the final and magnified image of the object P dash Q dash, and the first image P dash Q dash and the object P and Q. Now you have to observe this structure, that is made angle is alpha when a ray is passing through the optical center, and backside of the objective piece the angle made is beta. Here you have to very attentive to know about this angle is equal to this angle. Here alpha and beta is the little and very few smallest angle due to less aperture of the objective piece. The distance of the object, that is UE, made an angle alpha, and VO, that is the distance of first image from the objective piece, that is VO. And the image of P dash Q dash, that is distances from the eyepiece by the VE, which is as similar as the distance of the beta angle from the objective piece. Now we study about down to the principal axis. Here the first image P dash Q dash of the object P dash PQ, which is away from the eyepiece, that is MO, that is the magnification of the first image. ME, the second magnification of the image P dash Q dash. Image of the image P dash Q dash. And so therefore we can write P dash Q dash is the final image of image P dash Q dash by the magnification power of the eyepiece. The distance of eyepiece is VE, that can be measured in diopter. It qualifies the power of the lens of eyepiece. We have now study about, due to less aperture of the objective piece and the eyepiece, we have get a minimum angle. We have get a minimum and least angle from both the lenses. So therefore we come to the magnification power of the compound microscope. Compound microscope. Magnification M equal to angle of beta by angle of alpha. It is IP and it is OP, objective piece. Capital M indicates the magnification of a lens is the ratio of angle of image and the angle of the object. That can be right M equal to beta upon alpha. Alpha and beta are much smaller. So much smaller, so it can be write as the study of trigonal ratio tan theta is much larger than cos theta is much larger than sin theta. So angle is much larger, so we can write alpha equal to tan alpha, beta equal to tan beta. So m equal to tan beta equal to tan alpha. Here tan beta is the least angle deviation of eyepiece and tan alpha is the angle deviation of the objective piece. Tan beta is the smallest angle, that is of triangle P dash Q dash to the optical center. So M can be written as P double dash Q double dash by EP double dash upon tan alpha is P dash Q dash upon EP dash. We must write it M equal to P double dash Q double dash upon EP double dash into P dash Q dash upon EP dash. Here P double dash Q double dash, P dash Q dash, both are the ratio of EP double dash and EP dash. Magnification, it P double dash Q double dash by EP double dash P dash Q dash upon EP dash define the magnification of eyepiece. This is the eyepiece and objective is this. So we can write M equal to ME into ME. Objective piece, that is MO. Now calculate the relation of these ratios according to the structure of the compound microscope. Here M equal to we have ME into MO, magnification of eyepiece and magnification of objective piece. We have studied the lens formula, that is 1 by V minus 1 by U equal to 1 by F. this distance VE, VO, that qualify the image distance and the object distance. So we have putting the value of image and the value of object distance regarding with the length formula 1 by V minus 1 by U equal to 1 by F. Both image distance and this object distance are negative, so 1 by VE minus 1 by minus UE equal to 1 by F. It can be written minus 1 by VE plus 1 by UE equal to 1 by F. FE multiply both sides by VE, then this relation become minus VE by VE plus VE by UE equal to VE by FE. This can be eliminated, so minus 1 plus VE by UE equal to VE by FE, or VE upon UE equal to 1 plus VE by FE. Here this VE is equal to D. Now we put VE by UE equal to 1 plus D by FE. D indicate the clear vision of the object by the eyepiece. One image of PQ is P dash Q dash, that is not clear image, but their image is P dash Q dash. Here I indicate P dash Q dash is the final image of the image P dash Q dash. So this distance from the eyepiece to the P dash Q dash is VE, that is the distance of clear vision of an object image. So VE by UE equal to 1 plus D by FE. In other way, ME equal to VE by UE. It is not applicable. And not needed. So MO equal to VO by UO. Image of objective piece and distance of objective piece ratio is the magnification of the objective piece. Here you have to become most attentive. Magnification of objective piece is the ratio of image of the objective piece and the object of the objective piece. Here we have get MO ratios and the ratios of other. So we put these values of MO in equation first. Equation first is M equal to ME into MO. M equal to ME. ME, the product we get 1 plus D by FE. Few minutes ago we derived it, and MO is given here into MO VO by UO. It can be right MO equal to VO by UO into 1 plus D by FE. This is the magnification of compound microscope, संयुक्त और यौगिक सूक्ष्मदर्शी, which is applicable in laboratory, pathological place, detecting language difference, detecting urine culture and stool culture, and testing of blood in the field of medical science and also in engineering science. This is the magnification power of the compound microscope. Here we also need the length of compound microscope L equal to length from here to here, where the observer is sitting to observe what is the situation of an object in that instrument, that is the optical instrument. Then the length of microscope is written as VO plus UE. It is most applicable for the class 10th and class 12th board examination. So you must have prepared and study as listening my lecture and structure. Thank you.